Greetings, friends. Take a moment to settle in as we dive into the fascinating topic of machine unlearning and its impact on generative artificial intelligence. Today, we'll explore insights from a compelling research paper titled Machine Unlearning Doesn't Do What You Think: Lessons for Generative AI Policy, Research, and Practice. This work is a collaboration among experts from esteemed institutions such as the GenLaw Center, Microsoft Research, Stanford University, Google DeepMind, the Center for Democracy and Technology, Princeton's Center for Information Technology Policy, Google Research, the University of Washington, Stanford Law School, Lighthouse, Cornell Law School, Cornell Tech, West Virginia University College of Law, Northeastern University, Harvard Business School, and the University of Michigan. Now, you might be wondering, what exactly is machine unlearning? Imagine teaching someone to ride a bicycle and then trying to make them forget how to do it. In the realm of artificial intelligence, machine unlearning refers to methods aimed at removing specific information that a machine learning model has previously learned. This concept has garnered attention as a potential solution for various legal and ethical concerns, such as privacy rights under laws like the European Union's General Data Protection Regulation, or GDPR. However, the researchers caution us that machine unlearning isn't as straightforward as it sounds. Unlike deleting a file from a computer, you can't simply erase information from a model's memory. During training, models transform data into patterns encoded within complex networks of parameters. These parameters are not directly interpretable, making it challenging to isolate and remove specific pieces of information. For example, consider a generative AI model that has been trained on images, including those of a copyrighted character like Spider-Man. Even if we remove all images of Spider-Man from the training data and retrain the model might still generate images resembling Spider-Man. This happens because the model has learned latent information, underlying patterns and concepts that allow it to recreate similar outcomes based on its understanding of features like color, shape, and style. Moreover, users can inadvertently reintroduce the very information we tried to eliminate. By providing certain prompts, they might coax the model into generating outputs that reflect the removed data. This means that even diligent efforts to erase specific data don't guarantee that the model won't produce related content. Another critical point the paper raises is the difference between controlling a model's knowledge and controlling its outputs. While machine unlearning focuses on the former, it doesn't necessarily achieve the latter. Suppressing undesirable outcomes, like disallowed content or sensitive information, often requires additional methods, such as implementing filters or aligning the model's responses through training techniques that guide its behavior. The researchers also highlight that generative AI models are inherently dual-use technologies. This means they can be employed for both beneficial and harmful purposes. For instance, the same language model that aids in drafting educational materials could also be misused to generate disinformation. Therefore, solely relying on machine unlearning to prevent misuse is insufficient. In practical terms, this leads us to several important implications. 1. Technical limitations. We must recognize that machine unlearning has technical constraints. It's not a catch-all solution and cannot entirely remove learned concepts from a model. 2. Policy and legal expectations. Policymakers should set realistic expectations about what machine unlearning can achieve. Laws requiring the deletion of personal data may need to consider these technical nuances. 3. Collaborative efforts. Addressing the challenges posed by generative AI requires collaboration between technologists, legal experts, and policymakers to develop comprehensive strategies that consider both technical feasibility and legal obligations. In summary, while machine unlearning offers intriguing possibilities, it doesn't fully align with the broader aspirations for controlling AI model behavior. The paper encourages a nuanced understanding of these limitations and advocates for more thoughtful communication among experts in machine learning, law, and policy. Thank you for joining me on this journey into the intricate world of machine unlearning. It's a complex topic, but by exploring it together, we move closer to understanding how to navigate the evolving landscape of artificial intelligence. Until next time, keep pondering and stay curious.